Hello guys, so I've picked out a question from section 1.10. This is number 12 in that section. Keep in mind 1.10, it's all word problems and every problem is a little bit different. A lot of these are not going to follow the same format every time because they're based on whatever the scenario is in the word problem. So if you get to one of these and you're really stuck, go to the question help and either use the help me solve this or the view an example, and it'll give you a similar problem to kind of work through to practice. So the question help is going to be really useful, especially in this section. It's in every section, but it's really useful in this section. So for this problem, it says two vertical poles of length 9 and 10 feet stand 19 feet apart. So here's my 9-foot pole, my 10-foot pole. This total distance is 19 feet. A cable reaches from the top of one pole to some point on the ground between the poles. So we don't know it's in the middle. It could be more to one side than the other. It doesn't say. And then it goes to the top of the other pole. So it goes from one pole somewhere on the ground and then to the top of the other pole. So what they've done is they've labeled one of these distances x, and that automatically makes the other side 19 minus x because the full length is 19. Okay, so if this full length is 19, but we use this much of it for x, then the rest of it is 19 minus x. And it didn't matter which side they called x and which side they called 19 minus x, it would work the same either way. So it says express the amount of cable used, L, as a function of the distance of the cable from the 9-foot pole, x. So they want us to base this off of this side being x. So we're going to use L to represent the amount of cable used. So I'm guessing they're using L for length. Length of the cable, and that's total, going from one pole to the ground up to the other pole. They want the total length as a function of x. So it's going to be L using x. That's why they have L of x here. So I'm not going to have to type L of x, it's already here. So I need to figure out this length and this length and add them together because I need the total length. Now, pretty much what we should be seeing is, oh, this is a right triangle. Right triangles have formulas for us to use. We'll do this one first. If this is a right triangle and I'm trying to figure out this side, that's the hypotenuse. So we use our Pythagorean theorem. Okay, this is something they're expecting you guys to know from a previous math class. So 9 squared plus x squared equals c squared, whatever that is. If I simplify this a little bit, and then I just want c, I don't want c squared, so I square root both sides. Now one thing you got to be careful, you cannot turn this into 9 plus x. Square roots don't split over addition. You can't just square root the 81 and square root the x squared. It doesn't work that way. This is actually as simplified as we can get it. Since we don't know what x is, this is basically where we are. So that's for the smaller triangle. Then we're going to do it again for the other triangle. This will be a little more involved. Okay, but same concept. I have 10 squared plus 19 minus x squared. Notice how my parentheses are set up. So 10 squared is 100 plus 19 minus x squared. I need to actually FOIL 19 minus x with 19 minus x. You can't just square both pieces. That will be incorrect. Let me get where's my calculator? Okay. So 19 squared is 361. That's from the first pieces. Minus 19x minus 19x plus x squared. So if I write that in the right order, just because I like to, combining like terms, okay, so we have that for the FOILing of 19 minus x. Then again, I'm going to combine the 100 with the 361. Oops, not plus, sorry. So that's 461. We'll c squared. And just like before, I don't want c squared, I just want c. So really, we have the square root of that. Now, as ugly as this is, that's really as far as we can go. We can't simplify that anymore. So they want a function or a formula that represents the total length of the two pieces of wire added together, the total length. So when I'm typing this in, I've got the square root of 81 plus x squared, and I leave that square root, plus another square root of x squared minus 38x plus 461. Now I should have swapped that to x squared plus 81 just to be consistent, but it shouldn't matter. It should know it's right either way. So I have the length of the cable in the smaller triangle plus the length of the cable in the larger triangle to give me the total length of cable. The total length of cable. And that's it. So it seems a lot harder because our answer is really ugly, but we didn't have to do anything with our answer. Now what this means is they could use this formula, and based on whatever they decide to make x, they could calculate how much cable they're going to need. So if they decide to put x as, 3 feet, they could plug in a 3 everywhere and they would calculate how much cable they would need. So that would be kind of the use for this formula. Alright, that's it. Let me know if you have any questions.